In this video, we introduce EM Lab's TM Resonator, which is designed to measure low dielectric, low-loss materials from 1 to 10 GHz, including rods, films, filler powders, and cooling liquids for servers. In this demonstration, we will measure a 2 mm thick quartz rod and potassium sulfate powder, following the actual measurement procedure. First, let us introduce the equipment used for the measurements. A Keysight network analyzer, a control PC and TM Resonator material measurement software, and the EM Lab TM Resonator. EM Lab's TM Resonator supports these 7 frequencies, enabling a wide range of measurements. In this demonstration, we will show you a measurement at 10 GHz. First, let's look at connecting the network analyzer to the TM Resonator. Use a torque wrench to connect the cable to the TM Resonator. The connection is now complete. No calibration or attenuators are required. Now let's move on to the actual measurement. First, we'll start with the measurement of quartz. Launch the TM Resonator material measurement software and select the connected resonator. Next, enter the required sample dimension. For a quartz rod, enter its diameter. For a rectangular rod or strip-shaped sample, enter the specified thickness and width. In this example, enter 2 mm as the diameter of the quartz rod. In this demonstration, we will measure the same sample 3 times to verify measurement reproducibility, so we will register 3 samples. Once the samples are registered, press the Measure Empty button. Follow the instructions in the pop-up window to confirm that no sample is in the resonator, then press the Measure button. The software will automatically detect the resonance and perform the measurement. Next, press the Measure All button. Follow the instructions in the pop-up window to insert the sample. Once the sample is inserted, press the Measure button. The measurement will be completed in a few seconds, and the measured values for dielectric constant and dielectric loss tangent will be displayed in the software. Next, we will perform the second measurement. Since we are measuring the same sample again, it would be possible to simply press the measurement button once more. However, in actual measurements, factors such as the sample insertion condition may vary. To verify measurement reproducibility, it is important to remove and reinsert the sample before measuring again. Now that the second measurement is complete, we will perform the third measurement in the same manner. The measurement is complete, so let's take a look at the results. As you can see, even though we measured the sample by removing and reinserting it, both the dielectric constant and the dielectric loss tangent were measured with excellent stability. Next, we'll demonstrate how to measure powders. The powder is pre-filled into a special tube. First, register the sample information. Since the powder is measured while mixed with air, you'll need to enter a few additional details to calculate the value for the powder alone at the end. Specifically, you'll need the weight of the tube before filling, the weight of the tube after filling, the filling length, and the specific gravity of the powder. The following procedure is basically the same as for quartz measurement. However, for powder measurements, we take measurements at 3 different positions in order to reduce errors caused by uneven filling. A dedicated powder measurement stand makes this process easier. First, perform a blank measurement, then insert the sample and perform the sample measurement. This completes the measurement at one location. Next, for the second measurement, pull out the upper drawer of the dedicated powder measurement stand. This causes the sample to automatically drop down, changing the location where it is inserted into the TM Resonator. Then press the measurement button to perform the measurement at the second position. Finally, pull out the lower drawer of the powder measurement stand, just as before. This sets the sample at the third measurement position. As before, press the measurement button to take the third measurement. Once the measurements for all 3 samples are complete, the dielectric constant and dielectric loss tangent values for the powder alone will be displayed. You can see that even a powder with an ultra-low loss of 0.0008 can be measured without any issues. As demonstrated here, EM Lab's TM Resonator allows anyone to perform stable and reliable measurements with excellent reproducibility, regardless of the operator or the timing of the measurement. For powder measurements, We have confirmed that the values obtained when measuring in film form are identical to those obtained when measured as a powder, and you can verify these measurement values on our website. If you have any concerns about your current measurement system or need more detailed information, please contact EM Labs.